All right, Miguel, you said you had a question. 79. Is this 42x squared, that one? Okay. So number 79, 42x squared plus 47x plus 10. All right. So the numbers, I think, could get big here, right? First thing we looked at GCF. We don't have a GCF, right? So we go ahead, 3 terms. We go for the AC method. So that'll be multiplying 42 times 10, 420, and then 47 here. And so you have to try and figure out some numbers that work here. For 420, 1 and 420, not even close, right? 2 and 210, not close. 3 and 70, no. Wait, is it 3 and 70? No. 3 and 140, right? 4 and, no, whoa, no, 4 goes in there. 105, we're getting closer. 5 and 84, 6 and 70, 7 and 60, 10 and 42, 12 and 35. And it looks like the 12 and 35, right? So 12 plus 35 is 47, so unfortunately it was the end of the list here. So I'll put, did you put the 12 first and then 30? Okay, so we go 12 here, 35 like this. And then what we do is we rewrite this. We just bring our outside pieces down, 42x squared. We bring the 10 here. In the middle we put plus 12x and then plus 35x. And then we have plus 10. We do our grouping, right? So what number, or actually, sorry, what's the GCF out of the first two? 6x? So 6x, you're left with 7x plus 2. We need the same thing over here, 7x plus 2. So we put a 5. And so you're left with the 7x plus 2, which is what matches in both, and then 6x plus 5. Right?
I just got thrown off because it's
the big number? Okay. Okay, we have an exam on Tuesday. All right, we have our, what is it, third exam? So exam 3 will be on Tuesday. What day is that? The 15th. Okay, the things that you can bring. The formula sheet that I handed to you in class, right? You can have that. You can have one, I'll call it cheat sheet, even though it's really not cheating. Cheat sheet, and then on that, you can have what, like steps, procedures, anything with formulas, but just no worked out problems, right? That's the agreement. So no worked problems on that. Remember also to bring a calculator, because you will not be allowed to use your phone. All right, so make sure you have a calculator. Anything else? Pencil, erasers, things like that. Okay. Now, as far as a review for this, here's what we're going to do. I'm going to give you, right now, a huge list of problems that you should go home and do before the test. And what I'm going to do is I'm going to I'm going to pull these. I pulled these problems from the chapter review for chapter 6. So this starts on page 450. And what's nice about the chapter review is it breaks it up by section, and then the instructions tell you like factor by grouping. So they kind of lead you a little bit, at least in the beginning. And then when you get to 6.5, these problems, it's just here they are, try and factor it. So they don't tell you what to do. So if you want to prepare for this test, 5, 9, 11, 13, 17, 19, 20, 23, it's going to be a lot of problems. 25, 31, 33, 36, 47, 49, 51. Now those problems, all of them kind of tell you what to do, all right? Keep in mind though also when you're doing these problems, if it says like on numbers 47, 51, and 49, these, it says use the educated guess and test method. Well, we didn't do an educated test method. What we did was that AC method, right? So for all the problems that are trinomials, use the AC method that we did in class, you know, the one with the X and the grouping, right? So you kind of can ignore the book in that sense. But if it says, you know, use grouping, then use grouping. If it says use difference of squares, sum of squares, something like that, use that. Okay, so that's all those problems lead you to what you're supposed to use. Okay, now these problems, I'll do them in red, are more like what you would see on the test, which would be numbers 59, 61, 65, 67, 68, 72, 75, 78, and 80. Then keep going, hold on. Pardon me? Yeah, well, it's all on the yeah, we're actually moved on to the other page. It all starts on page 450 though. 81, 83, 85. I know this looks like an insurmountable amount of problems, but we'll talk about it. Let me just finish writing them down. 93, 97. Yep, there goes your weekend. If I were you, okay, and you feel pretty good about what we've been doing, all right, I would just start with these red problems, okay? Just start here. Now, if you find that you're doing these and you're like completely lost and you just don't know what to do with these, then maybe go back to those and start tackling those a little bit, you know, because if you do those, it's a little bit more leading you is what you're supposed to use. This one, there's no leading. It just, you know, factor, 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 factor. Now, the problems starting on page 81, these are solving equations. The ones up here are factoring. We ended class last time doing these. We just got to the beginning of solving. We're going to do more of these today, and then I'm going to do a formal review. All right. So my plan for the review is after the chapter review, there is a chapter test, and I am going to do problems from the chapter test that I think are great to prepare. All right. That makes sense? Okay. So let me start by reminding you what we did last time at the end of class. See if this looks familiar. Let me see. We had this thing called the zero factor property. Remember this thing? It said that if two things multiply to be zero, then one of them has to be zero, right? And then we went on to say, okay, well, if we start out with something like this, we have an equation now, and that left side, we want to try and make it something times something, then that means we want to factor it. So we did our cross and everything else, and then we did all that, and we broke it down, and then once we got to this part, which is where we used to stop, we had to take each one of these and set each one of those equal to 0. So So kind of this zero factor property and the way we use it, it's really everything we've done up to this point, factoring wise, with one additional thing that we have to keep the equal zero, and we have to actually solve it at the end. So we did another one. It was like this. We said, oh, okay, we have to make it equal 0 first, so we moved everything to one side, and then we did GCF, and then we set each of those to 0. Does that, yeah? Okay. Let me see, and then I gave you that to do in class as a quiz, right? At the end. I don't have those, right? At the end, I gave you one problem right before the end, and then you turned it in. So let's start with that. Okay, we'll start here, and then we'll do a few more of these, and then we'll start doing a real formal review. Okay, so for this problem, you're asked to solve, okay? That's the key that lets you know you're going to be using zero factor property. Right now, it's equal to 0 already, isn't it? So all we need to do is try and turn the left side into something times something. So that means we need to factor it. So I'm going to use what method here? AC method, because there's 3 terms, right? Do I have a GCF here? No? Okay. So what I'll do is I will take the 1 in front of the x squared, multiply it times negative 30, get negative 30. What number goes in the middle there? Negative 1? Just negative 1, right? That's all right. And now you come up with your 2 numbers. So if you do this long enough, I guess, I'll just do it real quick, but if you needed to, you'd have to write them down, right, and figure out what numbers do it. Looks like negative 6 and positive 5 will work. So then we write down the left side, watch, x squared comes down, 30 comes down. I have minus 6x. I have plus 5x in the middle, right? I split this. GCF out of the first 2. X left with x minus 6, right? The other one, I need an x minus 6 again. What goes in front then? 5, right? So plus 5. And then that will be, oh, what did I forget? Equals 0, equals 0, right? Bring this equals 0 down, right? Now what? Left side becomes x minus 6, and then in parentheses, x plus 5 equals 0. Now we're finally down to using the zero factor property. So I have 2 things that multiply to be 0. So what we'll do is we'll set each one of these to 0, right? Now the way that I did it last class is a little different than the way I'm going to do it this class. What I'm going to do is I'm going to just put a line down the middle, and I'm going to write down 2 equations. What I'm doing is I'm just taking what's in the parentheses, right? X minus 6. I'm saying that's got to be equal to 0, or the x plus 5 has to be equal to 0, all right? And then I solve each of these equations. And to solve those, what we mean is isolate the x, right? Get x by itself. So on x minus 6, to get minus 6 off the left side, I have to add 6 to both sides. So add 6, you get x equals 6. And you box it, and you're done with that one. And then on the other one, to get x by itself, subtract 5, subtract 5. Left side is x, right side, negative 5. 0 take away 5 is negative 5. I don't know if you noticed this, but isn't your answer the opposite of what's in here? Yeah. It is. That'll work only when this is just x, but we've seen when we factor sometimes that this is like, what if this was like 5x minus 6? You know what I'm saying? Then it's not just going to be 6. So that's why I don't say, oh, just take the opposite of what you see, because it can get a little tricky. So just work this out, huh? Well, yeah, let's do one, okay? So you can see what you would have to do. But that's it. Any questions on that? Okay, let's do this one. How about if we had 2x squared plus x minus 3, or you know what? Let's do this. Plus x equals 3. And the instructions here are to solve this equation. You mean move it over to that side? Yes. That's the first step because we have an equal sign, but it's not equal 0. And remember we said on the zero factor property, it only works if one side is 0. Like it doesn't work if the other side is 3. So what we have to do first is move the 3 over to the left. How can I move the 3 to the left? Subtract it. So subtract 3 on both sides. And what we'll have is 2x squared plus x. Take away 3 equals 0. Now you're free to try and break down that left side. So on the left side, what are we going to use? The AC method, right? There's no GCF here. So AC method. Now because time and because we want to really like move on and talk about review and get through this, I'm just going to show it factored without showing any of the work, okay? So if you did AC method ... then here's what you would get. You get 2x minus or plus 3 times x minus 1. That's what you would get had you done AC method. All right? Let's just check it. 2x squared, that gives me this. 2x times negative 1 is negative 2x. 3 times x is 3x. When I put 3x and negative 2x together, I get just x. And then 3 times negative 1 is negative 3. So that is correct. But now what we need to do is we need to take each of these and set them equal to 0, right? So I'm going to draw my red line here. 2x plus 3 equals 0, and x minus 1 equals 0. Now, because the x minus 1 is just x, the answer is going to be the opposite of what's here. The answer is going to be 1, but this one is not going to be negative 3. You have to do some work. So let's do the one on the right first. Add 1 to both sides. So you get x equals 1. Now, on the left side, I'm trying to get x by itself, right? The first thing you do is isolate the x term. That means get the 2x by itself. So you will still move the 3 over. So you subtract 3 on both sides. And that gives you 2x equals what? Negative 3. And then to get rid of the 2, because it's multiplied, right? 2 times x, you will have to divide 2, not subtract. So divide 2 on both sides. So divide by 2 on the left, divide by 2 on the right. So x is equal to, and just leave it as a fraction, negative 3 over 2. That's it. See how that's a little bit trickier? So that's why I don't like to just say, oh, just take the opposite of what you see, because sometimes it's not the opposite of what you see. Questions? All right. How about I want you to look at this example. I'm going to write down 2 things here. X plus 2 in parentheses times x minus 3 equals 0. And then next to that versus this problem, totally separate problem. X plus 2 times x minus 3 equals 14. Let's look at the problem on the left. I have equals 0, don't I? It's already factored. So since it's already factored and it equals 0, can't I just set each of those factors equal to 0? And then I'd be done, wouldn't I? So I'll do that quickly. I do x plus 2 equals 0. I do x minus 3 equals 0. Solve each one. So on the first one, I would do what to both sides? Subtract 2, I get x is negative 2. On the other one, I would do what? Add 3, and then I get x is 3. And I'd be done, right? Clean, easy, no, I mean, I didn't even have to factor. That problem was ready to go, right? Compare that to this problem. Can you use the zero factor property here? No, because it does not say equals 0, right? So you might say, all right, let me get the 0 over there, right? How do I get 0 over there? Subtract 14. Now, don't write this down yet, okay? I just want you to see what would happen. If I subtract 14 on both sides, I wouldn't be able to do anything except put a minus 14 next to it. So I just rewrite what I have here and then minus 14, right? Can I use the zero factor property now? Well, I have something times something, right? But then what? Minus something. And to use zero factor property, it's got to be something times something times something. It's got to be multiplication the whole way. You cannot use zero factor property here. Not yet. Okay? Not yet. This is a very tricky problem. I'm going to put one like this on the test, so I don't want you to get caught on this. All right? Yeah, it's going to be there. All right? I'm going to give you one like this, and I'm going to give you one like this. I'm not going to put them side by side like this. You're going to have to know. But this one right here should require very little work. This one's going to require a lot of work. If you try and do what you did here, like if you take x plus 2 and x minus 3 and you set them equal to 14, you'll get nothing for that problem because that's completely wrong, right? So how are we going to do this? Well, here's how it's done. What we will do is we will take the left side and we will FOIL it out or expand out the expression. So multiply it all through, okay? I know that seems very unnatural because you're like, wait, you're supposed to factor. It's already factored. Why do this? Just put everything together? Yes. Like x plus 2. I'm going to do that times that, which is going to give me what? X squared. Then I'm going to do this times this, which is going to be negative 3x. The middle one, plus 2x, and then minus 6 equals 14. Now bring the 14 over. Okay? What's going to happen when I bring the 14 over? I'm going to subtract it from 6, right? Now what is negative 3x and 2x going to become? Negative 1x, right? Negative 1x. And then you said just subtract 14 on both sides, right? And when you do that, I get what? On the right side, I get what? 0, which is what I want. But on the left side, what's negative 6 take away 14? Negative 20. Negative 20, right? Now what we have is a new trinomial equal to 0, don't we? And now I can do AC method on that. And when we do AC method on that, it is not going to turn into this. It will not, because we brought that 14 over. So let's see what happens with AC method here. I have a 1 in front, 1 times that. Doesn't it give me negative 20? And then on the bottom, I have a negative 1. What two numbers do that? Negative 5 and 4, right? So then you go through and you bring your x squared down. You bring your negative 20 down. You go negative 5x and plus 4x in the middle. Split it. GCF out of the first two. X left with x minus 5. We need to match that over here, x minus 5. So what should go in front of it? Plus 4. And now that turns into, equals 0, equals 0. Turns into x minus 5 times x plus 4 equals 0. Now you can apply the zero factor property. So what will the two answers be here? 5 and negative 4. So this is where we would split it. X minus 5 equals 0. X plus 4 equals 0. And solve. X is 5. X is negative 4. Okay? Please don't get burned on that problem, all right? We'll do one more of these solving problems, and then we'll start the review. I mean, this is part of the review already, all right? Let's see. How about if we have 8x squared minus 10x plus 8 equals 5. The instructions here are to solve. What are you going to do first? Subtract 5 on both sides, right? We need this to be equal 0. Right now it's equal 5. So I'm going to subtract 5 on both sides to start out. I'll have the 8x squared, the minus 10x. Then what? Positive 3 equals 0. Okay, now can I do any work on this? AC method on the left side, right? Do I have a GCF though? Just make sure. No GCF. Okay, AC method. So I come up with my little cross now. I've got what, 24, negative 10. How about negative 6 and negative 4? Do y'all agree with that? So yeah, maybe it takes you a little more time to get that, but those will be the numbers. I rewrite this, 8x squared minus 6x minus 4x plus 3 equals 0. So bringing down the ends, rewriting the middle, using those two numbers. Let's pull the GCF out of the first two. 2x leaves you with 4x minus 3. Just the 3, because you have the x out there, right? Now you need that to match over here. Be careful. Look at this one. You need to match. The other one here needs to be a 4x minus 3 also, right? I need these two to match. 4x, I need to turn it into negative 4x. Negative 1 out in front. Good. Equals 0. So we get, they match now, right? 4x minus 3 in parentheses, other parentheses, 2x minus 1 equals 0. Now can I apply the zero factor property? Yes. So I split this up into 2. 4x minus 3 equals 0. Other one, 2x minus 1 equals 0. Let's look at the first one. What are you going to do on this first one here? Add 3 to both sides. Good. When you do that, you come up with 4x equals 3, right? Now, divide by 4. When you divide the left side by 4, it goes away. When you divide 3 by 4, you get 3/4. So your answer is 3/4. Other one, add 1 first. You get 2x equals 1. Then, divide by 2, you get 1 over 2. Done. What do y'all think? Okay? All right, so now I really don't care how to go about the rest of the review. I can either give you the problems out of the book and let you work on them, or I can just sit here and work them. What do y'all think? I mean, you want to work on them? Yeah? Y'all want to try it? If I give you these problems, these are problems that I think you would, like on a test, these are the problems you'd walk into. So maybe it'd be worth it for you to just sit there right now and see how you do on it. You can use your notes, you can talk to each other, but, you know, I was talking to some colleagues about student struggles, right? Like testing struggles. And we were talking about, do students prepare properly for a test? Because they think they do, right? I looked over all the homework, I did all the homework. You know, what you should really prepare yourself with is you should give yourself a set of problems, write them down on a piece of paper, have nothing else on the table, just work it like you're sitting there taking a test. Practice the testing environment yourself at home. You know what I'm saying? Don't be sitting there with the TV on and you got your phone and you're, talking to your friends or what, try and give yourself, okay, 1 hour. Can I do these problems in 1 hour? And practice that. Okay, so let me give you some problems out of the book. If there's not a book on every table, then I'll make sure that we match people up. Let's go page 543. Oh, no, 453. Number 6. Number 8. Number 10. 11. 12. 13. 14. 17. Now, those are the ones you should do right now. I already did just now in class 18, 20, and 21. Those were part of what I was going to do in class today. These are the problems we just did, the solving ones. If you look in the chapter on this page, those problems I just did. All right. So I would look at those blue ones right now. That's what, 6. That's 8 problems. I'm thinking your test is probably going to be somewhere around 10 to 12 at the most. So let's see if you can do in the next, like 40 minutes, how many of those 8 problems you can do. Okay? Anyone need a book? You all need a book over there? Can you all share? You know what? Since it's only 8 problems, how about I just write them down? I'll do that. Oh. All of these problems say factor. What's the first step to factoring? GCF, right? What else had I said? 14 and what? 17? 17, okay. All right. See how you do on those, okay? Stop this recording.